All right, how's everybody doing today? This is Mr. Leisman. I'll be taking you through 9191A, which is dealing with ellipses. There are 3 review questions here. Please get to those, and then I'll come right back and we'll talk about them. Pause the video. Okay, hopefully these are the answers that you came up with. In this first one, take 3x and set it equal to pi over 2, because if it just said sine of x equals 1, pi over 2 is where sine is 1. Add 2 pi k, and then divide both sides by 3. What's the log of 10,000? Well, that would be 10 to what power gives you, sorry, not 10,000, but 1,000. Well, that would be 10 to the 3rd power, so the log of 1,000 is equal to 3. And then solving for this, you would just take the natural log of both sides, and then so you'd have something that said the natural log of 5 to the x is equal to the natural log of 10. Remember, the rule says you can take this and move it to the front and then divide both sides by ln of 5. So ln of 10 over ln of 5, you put that in your calculator, you get an answer. All right, today we're going to be talking about ellipses. We're going to be talking about basically how to graph them. Sorry, let me get this going. The ellipse, it's the standard form is where the center is at the origin. And they look, or should look, fairly familiar. Notice here it's saying x squared over a squared plus y squared over b squared is equal to 1. In the second one, they're saying x squared over b squared plus y squared over a squared is equal to 1. So the difference is the a and the b. And that kind of tells you whether you have a horizontal stretch of a circle or you have a vertical stretch of a circle. Notice here that a squared is always going to be bigger than b squared, and a and b are always going to be positive. Also note, when a and b are equal, then a circle would be formed. X squared plus y squared equals r squared. So we have those 2 situations, and a and b are what are important here in terms of our stretching situation. So we're going to talk a little bit about this and what actually happens here. I'm just going to draw one just so we kind of see what's happening. Here would be my center. And let's just say I go out to, let's say, 5 on the vertical and maybe only up to 3 and down to 3 on the horizontal. So I have this thing, and when you go to draw these, just do your best. They're hard to draw sometimes. So we have something that looks like that. Couple of things to point out to you when we have this situation. We're going to have our vertices. The vertices for this particular one, we're going to have an a value here. So it's going to get stretched. If I look at this one up here, this one is the horizontal, a being bigger than c. So a would be this distance from the center out to here. That would equal a right there. B would be this distance right here. And then we also have one more piece of the pie, and that would be C, which would be considered the foci, and we'll talk about how you find that in just 1 second. So let's take a look. First of all, our vertices. Our vertices here are going to be plus or minus a, 0, because we are on the axes here. So because we're on the axes, we would center everything around 0. Our center, well, that would be at 0, 0. That's always going to be the case here. Our foci. Now, to find the foci, it's going to be plus or minus c, 0, where c squared is equal to a squared minus b squared. So very similar to Pythagorean theorem, which we will actually use later to solve some of these c value problems. So our c, when we found this situation, if I know a is 5 here and I know b is 3, well, then it's going to be c squared is equal to 25 minus 9. C squared would be equal to 16. So C would be plus or minus 4 in this problem. So you would go out to 4, and here would be what are called the foci points, or the foci, however you decide you want to say that. So that would be how we would find those values. So this right here is C. Hopefully that kind of makes sense here in terms of what we're trying to do. When you talk about these, a couple things to point out to you. In particular with the C values, when you're talking about the C value, if you were to take a line from this value, let me write it off to the side here so we can kind of see it. Let's say I've got this oval, and here is all of this running this way, and here's this running this way. And let's say that we have our foci points, are right here and right here. If I were to draw a line, take it from here and hit the edge of this thing, well, properties that involved with this, it would bounce and go straight to this one. And it doesn't matter where we actually do this, it's always going to be the case. I could draw it back this way and it would bounce and go this way. If I call this one D1 and this one D2, well, if I take D1 and I add D2, it's some constant value, the lengths of them. But it doesn't matter where your D1 and D2 are. I could say this is also D1 and this is D2. That same distance is still going to be the exact same constant. So it doesn't matter which way you draw these. That is one of the particular properties that go with an ellipse. And in thinking terms of this, before I really get too far into this, this whole section is called conic sections. They call them conic sections because they are slices out of a cone. And when you're talking about slices out of a cone, you could create parabolas, hyperbolas. What we'd have is like an inverted two cones put together for hyperbolas. Ellipses, you can, instead of taking a completely even circular slice out of a cone, you could make it kind of stretched one way or another. One of the remarkable things about conic sections is that they were created or studied over 2,000 years ago by the Greeks. And 2,000 years ago, they had no concept of how they were going to actually be used. But now everything we do, we build bridges, there's conic sections. We have radio waves, and like doctors use machines that like pulverize kidney stones, and they use that with conic sections. So a lot of interesting things. Also, if you think about it, if you go down to the middle of where you walk in the doors of Reno High School, there's a conic representation on the ceiling right above you that makes all those weird kind of noises. That's kind of the same idea. When we talk conic sections, we'll get further into this and you'll kind of hopefully understand that's what you're seeing. Back to here though. The major axis, usually when they want that, they want the length of the major axis. That's usually what they're talking about. This is horizontal in this case. And it would be considered 2 times A in this problem. The minor axis here, they're also asking for the length of the minor axis. This one would be vertical. And it would be found by taking 2 and multiplying by B. Our x-intercept, well, we've got 2 of them, and in this case, you would find them at plus or minus A, comma 0, and your y-intercepts you would find at 0 plus or minus B. So hopefully that makes sense. If we were to take the vertical picture of this, well then if I go up 5 and down 5 and right and left 3, now you have one that's kind of doing something like this. Once again, draw them as best you can. But all of the things are going to be the same. Now, the difference. The major axis is now vertical. Here we have vertices now that would be starting at 0 and going to plus or minus a. The center, well, that would still be at 0, 0. Our foci point now is going to be plus or minus c. It's 0 plus or minus c. The length of our major axis, well, now the major axis here is going to be vertical. And it will be, the length will be 2 times a. That doesn't change. The minor axis is now horizontal. And it is at 2 times b. Our x-intercepts would now be plus or minus b comma 0, and our y-intercepts are 0 plus or minus a. So those are all the parts that we would really talk about. Let's just kind of take a look at a problem. I always find it easier to just kind of work through a problem, and then that kind of gives us an idea of how to make these go. So here's our question, or our equation. X squared over 16 plus y squared over 25 is equal to 1. So first thing we got to do is identify what a and b are. And remember, in these, a is always going to be the larger value. So a squared would be 25. So that means a is equal to plus or minus 5. And b squared in this problem would be 16. So b is going to be plus or minus 4. So all of the things that we looked at here, first of all, vertices. I'll just say vertices up here. Our vertices, this is a stretched vertical situation, so I'd go up in this problem. I go up 1, 2, 3, 4, 5. It's right here. I go down 5. And then my b value is plus or minus 4, so I'm going out 4 both directions. And now it's going something like this. A little off, but not too bad. So now we need to find all of the things that go with this particular problem. So with that in mind, vertices, well, what are our vertices? In this one, our vertices would be considered 0 and plus or minus 5. So 0 and plus or minus 5. Our center in this problem, well, that's at 0, 0, didn't change. Our foci for this problem, well, the foci is found by saying c squared is equal to 5 squared minus 4 squared. That's going to be c squared is equal to 25 minus 16. C squared is equal to 9. So c is equal to plus or minus 3. So the foci are going to be at 0 plus or minus 3. So I go up to my picture. Those have to be in your picture. There's plus or minus 3. Okay, hopefully we see there. The length of our, so I'll say length of the major axis. Well, the length of the major axis in this problem, it's going to be 2 times a, so 25. And the length of the minor axis is equal to 16. Sorry, not 16 and not 25. 2 times 5, that's 10. 2 times 4, that's 8. So those are our two lengths for those. And then their x and y intercepts, well, we already know what those would be. This is a situation where we have x intercepts at plus or minus 4, 0. And you can write them like that as long as they're the same y value in their coordinate point. And our y-intercept, well, that's going to be 0 plus or minus 5. So those would be all of our answers. This is what our actual picture would look like, and you're done. Graph them by finding a's and b's. Now, unfortunately, they don't always get centered at 0, 0, so there are times where we're going to have to do a little more work with these. In this particular case, it's going to say the following, that x squared minus h x minus h, all of that squared over a squared plus y minus k, all of that squared over b squared is equal to 1. So we're just shifting just like with a circle. You have an h and a k that tells you where your center is. So hk tells you where your center is. And your vertices and foci are moved respectively. So if we think about this in terms of how we're moving, the k value is just up or down. But then to find the vertices, we're going to have to shift our h value. So for the vertices, we would see that we would have h minus a, comma k, or h plus a, comma k. That would find you your vertices. The same would happen with your foci. You would have h minus c, comma k, and h plus c, comma k. Those would give you your foci. If your major axis is horizontal, because your x is what you would base that off of. For your vertical, it would be just pretty much the opposite. Your h would now stay the same, but now you would have to shift your k value plus or minus a distance to get your new verticals, or your vertical vertices. And then your foci would be the same idea here. You would be shifting versus your k, and you would be subtracting your c value and adding your c value. So hopefully that kind of makes sense there. When you go to graph these, that's really how they go. So now here, notice it's not saying what you need to find, okay? What I would tell you is that you do want to be able to state them. You should be able to state everything that we talked about on that first page, no matter what form this takes. So let's look at this first one. You have 25 and 16 for your A and B, and A is under the X value. That tells you this is a horizontal axis. So it's being stretched horizontally. So first things first, you want to find your A. Well, A is really 25 square root of 25, which is 5. And we'll say, for the sake of argument, plus or minus 5 here. But remember, we're talking the distance that we're going to take away from the h value. In this case, we're not talking about the fact that the length of that thing is actually negative. Our b, well, our b is going to be 4 plus or minus 4 in terms of which direction we're going. But they did say a and b are always positive. So just keep that in mind. We're not talking about lengths here. You need to find the center. You find the center by doing the following. It is c squared is equal to a squared minus b squared. So c squared is equal to 9. C would equal plus or minus 3. So we have those values. So how do we find our stuff? Well, first of all, we find the center. The center is at 2, 4. Keep in mind, that's the center. And it's always opposite of what you see. Now, normally when we were doing these before, when you did them last year, h and k, h was always opposite and k was always the same. But h is always attached to the x in those old problems, and k never was. Well, k is now attached to your y, which means it's the opposite thing. So our center is at 2, 4. I go over to 2, I go up 1, 2, 3, 4. Here's the center. And now I want to find all of those things that I need to find. Well, I need to find the vertices. And the vertices are going to be, in this case, we have to adjust our h by subtracting and adding. So for our h value, we're going to have 2 minus 5 and a k value of 4. And we're going to have 2 plus 5 k value of 4. So 2 minus 5, that's negative 3. 1, 2, 3, 4, 5. That's right here. And 2 plus 5 is 1, 2, 3, 4, 5. That's right out here. And then that's for our vertices. For the other ones, the foci points, we have to adjust using the 3. So we're going to do that in just a second. I know my b value is plus 4, so 1, 2, 3, 4 puts me up here, and 4 down puts me here. So here is my And this should be a little more rounded here. Kind of hard to do sometimes. It still doesn't look very good. Let's see. All right, a little better. All right, so now I need to put in my foci points. My foci is going to be the h, which is 2, subtracting the c, which is 3, 4, and 2 plus 3, 4. So it's telling me I'm going to go 1, 2, 3 this way, 1, 2, 3 this way. There are my foci points. Hopefully that makes sense. Now, if I want to find all the other stuff, the harder ones to find are going to be two of them. First of all, let's just go, major axis here. The major is going to be a length of 10 because it's 2 times a, which is that. The minor length is going to be 4, so that's 8. So there's our major and minor lengths. Now, the last thing that you would be asked to find, and you could be found, or could be asked to find, if you were to try to find where these things are crossing the y-axis, crossing the x-axis. The x one is pretty easy because I'm looking at the x one and it looks to me like it's just going to be touching right here at 2, 0. So that makes sense. But finding these other two are going to be a little more difficult. But remember, the goal would be to find your y-intercepts. And if you're looking for your y-intercepts, then your x always has to equal 0. So plug 0 in, you're going to get some sort of fraction. You subtract it over, you're going to multiply by 16. You're going to take the square root of whatever all that is, and then you're going to add 4 to that answer. That would be how you would find the y-intercept. And if you were looking for your x-intercepts, then you would make y equal 0, and you would do that math to solve for x. They're not asking you that here, but that is something that we will be asking. So you need to know how to get those. Example number 3, I'm looking at example number 3. I see here that the a squared is the bigger value. It's under the y. So it's telling me this one's getting stretched. It has a center at 1, 0. So I go over to 1, 0. It's right here. And it's got a center right there. And now I just need to add and subtract. This is a vertical, so a is going to be 7. That means we go up 7 from here. That would be 1, 2, 3, 4, 5, 6, 7. And we go down 7. That's right here. The b value in this problem is going to be 3. So we go right 1, 2, 3. We go left 1, 2, 3. It's right there. This is going to be something that looks kind of like that. Like I said, do your best to draw them. In this case, I need to find certain things. I know what my center was. I already said that. We need to find the foci. So foci in this case, it's c squared is equal to 49 minus 9. So c squared is equal to 40. C would equal the square root of 40. And so that equals 2 square roots of 10. So that would be 2 square roots of 10. Now, that's just, square root of 10 is just above 3, and 2 times that would give you 6 something. So you're going to be, I'll do this with a different color. You're going to be somewhere close to your vertice points. Something like this. That would be your picture in terms of what you're looking at. Keep in mind, to state what those points are, what would you have to do? Well, you would have to shift your k value, correct? So in this case, the foci points would be over 1, and then you would have from 0, because y is 0, you would have to add 2 root 10 and subtract 2 root 10, so that's just plus or minus 2 root 10, and that's how you would state the foci point. You would be stating it as an exact answer, not as an approximation. Hopefully that makes sense. Your major here, Your major axis would be 14. Your minor axis would be 6. It's pretty much the pieces that you got to find. Like I said, sometimes they're going to ask you for the other part of that, the how to find the, sorry, I'm still thinking in my mind. They're going to ask you how to find your x and y intercepts, so you've got to be prepared to just plug x in, solve for y. Plug y in, solve for x. All right, example number 4. Example number 4 is saying that we have a center, but first, notice this isn't in the same form exactly because they got a 16 right here. So what we're going to need to do is divide everything by 16. Well, when we do that, we're going to get one that says this. If I divide this one by 16, that's going to be a 1, and that goes away. And if I divide that by 16, I get a 1. I have to make it look like this. Otherwise, you cannot solve this. So once I have that, what do I know A is? Well, A is the larger one. It's under X, so this is going to be a horizontal stretching of our circle by a factor of 4. Our B value here is just 1. So I know that my center is going to be at -2, 3. So I go to -2, I go up 1, 2, 3. It's right here. Now I know my A was 4, so 4, 1, 2, 3, 4 in this direction. 4, 1, 2, 3, 4 in this direction. My B is 1, so I'm up just 1 on both of the B values. This thing is looking something like this. Whoa, that got away from me. It's going to do something like that. Going to be a little bit skinny on the one end here. Let's see if I can get this to sort of work. All right, something like that. Now I need to find the foci points. And I find the foci by doing just what we were saying before. C squared is equal to, this is a squared, which is 16 minus 1. So that's going to be c is equal to the square root of 15. That's almost 4. So I would be going out almost 4, which tells me I'm going to be somewhere just short of my vertice. Hopefully that kind of makes sense. What are those points? Well, remember, we are getting, hold on a second, foci. We're adjusting our h value here. So we would say this is -2 minus root 15, comma 1, and -2 plus root 15, comma 1. And if I'm just stating them without doing the math, we can state it like this. -2 plus or minus the square root of 15, 1. That is how you can state this answer so that you understand, hopefully, that that's really how this works. The length of our major is 8. The length of the minor would be 2. Was there anything else here that we would need? I don't think so. I think that's it. So all the pieces that you need to come up with right there. And like I said, once again, if you have to find the x or y intercepts, put in, if you're looking for the y-intercept, make x equal 0 and solve. Put in the 0 for y if you're trying to find the x-intercepts and solve for x. All right, last one. This one's already in the correct form, except it doesn't have that part, but we can hopefully understand that's the case. And since there's a 4 out here, we have to make this equal 1. It always equals 1, no matter what. So any number that's out there, you're going to have to adjust by that, which means I got to divide everything by 4. So that turns this into a 4, and it turns this into a 16. Hopefully we see that. This is a vertical situation. It has a center at 2, 1. So I'm going to go to 2, 1. It's right here. It has vertices at the following places. A in this case would be 4 and B would be 2. So it's going to have vertices up and down by a factor of 1, 2, 3, 4. Here's this one. And down 1, 2, 3, 4. That's this one. It's going to have B values of 2, so we're going left 2 and right 2. So here's our picture. So our vertices here are going to be at, it looks like over 2 and up 5, and over 2 and down to -3. Those are our vertices for this one. Foci points. Well, just like before, c squared is equal to 16 minus 4. So c squared is equal to 12. So c would equal the square root of 12. Taking out the perfect square of 4, you're going to get 2 root 3. So this is going to be 2 root 3. That means that our points are going to be the following. You're going to go over 2, and then it's going to be 1 plus or minus 2 root 3. Those are going to be your foci points. But I got to put those in. Square root of 3 is 1.7 something. Multiply it by 2, it's about 3.4. So you're up. Let me do that with a different color. You're up to here. You're down to here. Somewhere in there. The length of your major would be 2 times A, which is 8. Length of the minor would be 2 times 2, which is 4. And that would pretty much be